Hello, I'm Dr. Rodolphe C from the University of Southampton, UK. And for a number of years with some colleagues, we have been interested in the reprocessing of reusable surgical equipment. With my co-author, Professor Bill Keevil, we are delighted that our latest study called Residual Persistent Contamination in Endoscope Channels, an epifluorescence study, has been accepted in the Journal of Endoscopy. As you probably know, the UK has been a victim of a serious healthcare crisis a few years ago with the apparition of variant Creutzfeldt-Jakob disease. The big problem was that this was transmitted by proteins only, and therefore, because of the wide tissue distribution of variant CJD, there was a fear that all sorts of medical procedures could lead to infection. This prompted a lot of research in the decontamination of instruments and looking at protein residues. One thing with stainless steel instruments is they can be autoclave, and you can heat them sufficiently to destroy the prion. This will also kill bacteria. Now, endoscopes are heat sensitive and can't be autoclave, so that brings a lot of questions and what is left in these. We have looked at new endoscope channels and old channels we recovered from decommissioned endoscopes. What we found in our study is just like stainless steel, proteins are easily adsorbed on the surface of plastic and metal within endoscope channels. One of the problems also is that these levels of contamination are not detectable by clinical staff, and it's even more difficult to see it when it's inside the long channel. What we did is spike some channels with test soils, and we found that proteins absorb immediately, and after the first cycle you clean it and it's still there, and you have the same level remaining for about 7-8 cycles at least. In old channels we found up to 3-4 micrograms of proteins per channel. One of the things also was the wearing of the channels was quite marked, and these scratch marks help absorbing proteins and other constituents. We found a number of biofilms in some channels, and these biofilms appeared partly abraded, maybe by the brushes used for the washing, or maybe during a procedures with the endoscopy forceps being pushed through. So our conclusions, what this make thing is, what is the potential hazard of these protein deposits inside channels? In UK we've got the fear of prion, so we are looking into more details on what these molecules are capable of doing, if they can be actually transmitted. The other aspect is obviously bacteria. In the recent years we've had a few cases worldwide, even in developed countries, despite respecting protocols, of iatrogenic transmission of bacteria through endoscopy, and these involved multi-resistant strains. So we've got on one hand an increased demand for endoscopy, and on the other hand the development of bacterial resistance. What we found in our studies on instruments and endoscope is that protein deposits are capable of absorbing the bacteria, and the bacteria may be masked to chemical treatment, which is the only options at the moment for endoscopes. So we are currently developing also new techniques. We are assessing new technologies developed in collaboration with engineer groups, and we see if we can make the decontamination better. So we hope that you find the paper interesting, and thank you for your time.